Okay, good morning, everyone. Welcome to the webinar dedicated to utilization of sensors in agriculture. Thank you for joining us. My name is Markéta Kolerová. I'm from the organizing association Plan for All, and I will be your host today. Today's webinar is organized as a part of ongoing Agrihub Inspire Hackathon 2022, where you can join our efforts and participate in challenges of your choice. Challenges number 5, 6, and 14 are closely linked to the webinar. You may check them on the Hackathon website, which will be posted in the chat. So today, our speakers will introduce SensLog, which is an open solution for sensor data management with its extending components, connectors, and analytics. They will introduce our web client application for the sensor networks called FIE20, which is actually a result of SmartAgriHubs Flagship innovation experiment number 20, integrating different datasets useful for farmers in one application. The webinar is recorded. The recording will be sent to your registered emails, and you can, of course, put any questions to the chat or after the presentation to the speakers, but for now, please keep your microphones muted. So it's about time to introduce the speakers. Mr. Michal Kepka from the University of West Bohemia, who's actually the main developer of SensLog, and Mr. Jakub Fuska from the Slovak University of Agriculture, who will speak about the role of sensor within the irrigation management. So, Michal, you may start with your presentation.
Thank you, Markéta. So I will try to share my screen. And let's see if it is work correctly. Okay, let's see.
Yes.
Yeah, it's okay. Good. Hello, my name is Michal, as Markéta said. So I'm from the University of West Bohemia, and with colleagues of university, company Lesprek-služby, and Baltic Open Solutions Center, we are developing open solution for sensor data management and building the whole environment for processing of sensor data. So SensLog is open and web-based management application for receiving, storing, managing, processing, and publishing sensor data. It is suitable for static in situ sensors. We can receive data from mobile sensors, so some sensor deployed on some carrier. It can be car, it can be tractor, or any machinery, or it can be connected to some smart devices. So we can use VGI data, or we can use smart applications to collect some spatial data. We are really putting emphasis on interoperability. So not only to collect data by our services, but we are trying to be interoperable, try to integrate from different sources and different services. This solution is modular and suitable for web environments. So it's deployed on web server and provides REST APIs on both sides. So we are communicating on this receiving part and producing web services for publishing. Data are mainly stored in relation database management system. So we are using PostgreSQL with spatial extension PostGIS. So this large database. We have developed own data model. It is based on ISO observation and measurement standard, but it's extended by, let's say, sensor network hierarchy, user hierarchy, and system of alerts, so some early warnings, some reporting messages. We have, let's say, 2 versions of the system. So first one, the old part, it's a very mature version. It's really web-oriented with integrated modules inside. So we have module for farm telemetry for VGI, And this first version is mainly communicating by own APIs, so proprietary API, REST services, and JSON data encoding. One of the standardized interface is represented only by OGC SOS version 1. So that was very limited communication. For version 2, is developed, let's say, last 5 years, 4 or 5 years. We put emphasis on higher scalability, and we put out these modules outside of the main core of the system and re-implemented them as standalone applications or standalone modules. Again, we are mainly focusing on proprietary APIs, so this is fully covering the functionality of the model and of the system. But to be higher level of interoperability, we are building some system of connectors. So we have, let's say, template of application, and this connector can implement final API, so from data producers or for data consumers. And one of the API we are implementing is OGC Sensor Things API version 1. So that's one of the components I will speak a little bit later. The proprietary API is covering the full functionality of the system. So you can store data, you can communicate with all the services. But the problem is that this API is only for, let's say, limited amount of third-party applications. So mainly the application developed in the team or in the big group of Plan for All. But it's very simple, and it's let's say based on JSON, so it's very straightforward to implement. But for, let's say, communication with other services or other components, we were really thinking how to connect to such services very effectively and very say usable for future development. So we are designing system of so-called connectors, and these connectors are mainly, let's say, transferring data between source API and destination API. So just some transformation of data between web services. So it's very quickly to develop it and just to connect to SensLog or to external servers. On this diagram, we can see very shortly how the data flow and how the structure of the system consists of. So on the left side, you can see different data sources from sensors, data providers, databases. The central part is components of or modules of SensLog. So from feeder connector, some processing part, analytics provider, to connector again, so it's outside connector. And on the right side, you can see destination applications, so smartphones, component for visualization, for publishing, or just destination storage of data consumer. So in brief, so on the left side, sensors, for example, this meteor station, and on the right side, some application, for example, chart visualization. To go a little bit deeply to connector application, so it's some gateway for interface definitions. It's mainly for tasks where we are no any influence for API design of destination or source data, and we would like to get this data or provide such data. So the option for such connector is in 3 modes. So we have some pushing data, pulling data, or proxy, just to switching between APIs. Same level is that is necessary, for example, to just load some part of such data. So we have implemented a list of allowed or blocked sensors. So on the right bottom image, you can see very shortly how it looks like in architectural point of view. At this moment, we have three use cases of connectors. So first is translating from SensorThings API to SensLog model. So this is the standardized interface. This use case allow push and pull mode, so we can store on load data. And the second use case is this proxy version. So we have OGC SensorThings API and AFAR Cloud REST API, which is interface of project architecture we were involved in. So this use case is just transferring data between no storage in the middleware, just transferring between two APIs. Or we have implemented in cooperation with Vessel Instruments API for file climate application. So we are able to download data from their data storages. Back to architecture. So in the middle, there is a component SensLog Analytics. So it's new component we are developing. And this component is responsible for analysis or some analytical processing of this raw observations we are receiving. Again, it's modular solution, so we are able to just deploy part of this application. So mainly tasks are focused on, let's say, statistical calculations, just to finding minimum, maximum, or averages, or monitor some thresholds. So, for example, freezing period or freezing days, or some overheating in greenhouses and so on. Or we are implementing some monitoring of combinations of values. So trying to find some patterns in data, or trying to, let's say, search for some combinations of values. So, for example, searching for good conditions for some destroying of crops, overheating, and so on. This analytics application can report some alerts to users, so by email, SMS, or sending just by alert objects to applications. Very shortly, how this analyzer is running. So it's just floating window and searching for accumulation of data or for these thresholds. Results are stored in same database, in different scheme, and it's providing data for visualization as well. So for some short visualization of long-term data. So just to visualize data averages, or day averages, hour averages, so on. In deeper looking on this data flow, so this analyzer is containing several components, so from filtering, thresholding, or some aggregation collector, up to let's say, again, publication of data or some events. Very briefly, two use cases of SensLog we are developing. One is this FIE20 application, so I will speak a little bit later, for static data in combination with remote sensing with other thematic spatial layers. And on the right side, you can see example of farm telemetry use case. So storing of machinery trajectories, analyzing with combination of let's say, field data, field blocks, and presentation to users as, let's say, work log or some effectiveness scheme, how this data can be used. Okay, so that's from this initial point of view about the SensLog, about the solution. And if you have questions at this moment, or we will keep it at the end of the webinar. So it's until I switch presentation, it's time for, let's say, one question. Okay, if not, I will skip to a second presentation. So this will be mainly about these two applications we are connecting to SensLog as data producer. We have two applications, SensClient and FIE20 Application, which is developed both the application on a similar team of University of Bohemia, Lesprek Služby, and Balticum Solution Center. So first, we are trying to extend the functionality of SensLog. So not only store data, some analysis, but to provide, let's say, this final application or end application for users. Mainly, it's focused on, let's say, extending the visualization part. So just not to look on numbers and data stamps, but to really see charts and maps. The first application called SensClient, again, it's a web application which is providing basic visualization of measurement. It's allow user management in sensor network. So who is able to see which sensor in which data group and so on. And it provides some insert and editation functionality for sensor network metadata. So rename sensor, rename units of measurement, rename the group of sensors and so on, or change group of sensors, which is very useful for, let's say, flowing between seasons and flowing between campaigns. In case of measurements, you can just visualize data. You can see the localization of sensors in map, and you can download data bar by specific parameters. So not only by timestamp, but by let's say list of sensors, list of measuring nodes, and different forms. Not only, let's say, timestamp, ID, and value, but with some metrics or different form of data. Now will be a slideshow of print screen. So after login, you can see a list of measuring nodes you have access to. So list of measuring units, and then you can look on the map where these units are deployed. By clicking on one unit, you can see a list of sensors that are connected to this measuring node. For example, this is meteo station. So you can see different sensors respective different phenomena that are measured. And then you can see on one specific sensors and one specific phenomena in defined time frame, or on the right side, you can see all these phenomena and just select which you would like to see. So for example, this is air temperature, soil temperature, and volumetric water content. So two different phenomena in one visualization. Then, as I was speaking, you can download some part of data. So, for example, at this moment we are looking on methane concentration between 2 days, and the style is this metrics download. And we will just select one node, and on the right side you can see example of this CSV file with data, so timestamp and value. Okay, this was the, let's say, application managing sensor data and just brief visualization. This FIE20 application is a completely different approach. So it's again web application, but it's integrating measurements, spatial layers, some analysis like meteograms, and set of further analysis. It's map application, so main part is map window, where you can see sensor networks. You can go through different thematic layers and to see results of analysis that have some graphical parts. The application is deployed on groundwater.bosts.lv, so you can look on this demo version. And what we would like during this hackathon prepare or develop is adding some analytical functions to the current one, and to implement functions for mobile sensors tracking or trajectory data visualization. So to see, for example, machineries, how they were operating in which days. Again, some slideshow about how this application looks like. So the main is map window, and on the left side you can see different functionality this application provides. This application is again based on HS layers, NG web mapping library. This library, I think, in set of this webinar will be mentioned as well. So this is the library developed by the team under Plan for All scope. In map window, you can see location of sensor nodes. And in the middle, you can see part of trajectory of mobile data. Again, this application can visualize measuring data because you can select from list of nodes and then select particular sensors and time frame, and we just visualize this set of data. You can visualize just one phenomenon or different phenomena in one chart. So at this moment, this is air temperature and soil temperature in one chart. You can combine this localization data of nodes or sensors with some meteograms or metadata layers. So, for example, this is temperature model for next 24 hours. Or we can visualize this tracking data. So select particular car or machinery you would like to see, select particular date when this machinery was operating, and the result is this trajectory of data. And we can, let's say, use some symbology to visualize other phenomena connected to this mobile data. So, for example, this is temperature of inner space for carrying food. So we can see that most of the part of the trajectory there was between 0 and 5 degrees Celsius inside of the car. It provides set of analysis as well. So, for example, this is a meteogram for the locality. So 7 days meteogram presenting not only weather forecast but different phenomena as well, or some basic analysis, for example, spring window. What we would like to do during this hackathon is it can be divided in two scopes. One is focused on the SensClient application. So we would like to extend this visualization part and extend download data methods. So to be able to provide users more variations of data downloads. For FIE20 application, we would like to extend these analytical functions mainly focused on Earth observation data and remote sensing data, so to be able to integrate results of analysis or classified images from remote sensing data. We would like to implement methods for interpolations or provide interpolated data visualization, especially for this dense sensor networks, to be able to interpolate data between nodes, and again integrate some remote sensing services to be able to act functionally for end users. And that's all from my side. Okay, so I'm a little bit shorter than expected, so now it's time for a few questions. Okay, if there are no questions, I would like to ask our second speaker, who is Jakub Fuska. Hello, Jakub. Can you join us?
Hello. Can you hear me, please?
Yes, very well. Thank you.
Okay. Thank you very much. Okay. So thank you for having me on this workshop. To be honest, as I have seen your presentation and your results and your progress, my presentation and our project is more down to the ground, and we are really in the very beginning of all of this. So I must say I'm a bit worried if all that I have prepared for today is enough for this meeting. But let's be honest, I'm trying to make maybe some inspiration or to say how the sensor works can be implemented for someone or for the users who have virtually or literally no experience with the sensors at all. So it will be more beginner's guide or our insights to the sensoric in the environment and mapping. If I can share my screen, I will try to turn on my presentation. Can you see what I'm sharing currently?
Yes.
Okay, thank you very much. So again, my name is Jakub Fuska. I'm working on the Slovak University of Agriculture, and our project, irrigation management, is dealing a bit with also with sensors and WebGIS publication of the sensor and processed data. Our task of our project is quite simple. We are trying to answer the questions of farmers who are running the irrigation systems, which are based or fed by water from water reservoirs, and the water level and the water amount is fluctuating. So that means we want to answer the question how much of water we have currently in our water reservoir. In Slovak conditions, there is about 200 water reservoirs that were in the 20th century built, especially for the irrigation or mostly for the irrigation purposes, also for the fish production, for flood protection, and so on. But those reservoirs are mainly from the 50s or 60s of the 20th century, and in our conditions, the problem of siltation occurs as it does in any country in the worldwide, and the problem is very significant without the proper cleaning of the reservoirs. What happens is that the water that is flowing into the reservoirs is also carrying some small particles of soil, organic matter, and so on, which is deposited in the water reservoir, which means it reduces the current capacity of the reservoir, which means less amount of water for the irrigation. Second problem is if we know the original amount of water in a given water level, we are dealing with the old data because currently, if the water level is at the same level as it was in the 50s, the water amount is quite smaller. This is why we decided to do our project. We are trying to monitor the water reservoir in the meaning of knowing water reservoir bottom model to assess the amount of water, and also assess the current water level by sensoring it by our prototype of sensor to provide the information of how much of water is remaining in the water reservoir. This means that the farmer has current and actual information of current status, and we are also trying to incorporate the information from the watershed, meaning soil moisture in the watershed, and also the weather forecast, which will tell us in, let's say, 5-day advance how much of water we are expecting to fall on the watershed, and how much of this water is flowing inside this water reservoir, which is then available for the farmer. This will help the farmer to decide how much of water he can use during this irrigation process, and it will be beneficiary for him mostly in the future as the climatic change is advancing, and it will be crucial to know how much of water we are dealing with currently and how much of water we have available for a few next days in advance to the weather forecast. We have a small study area which is located near city of Nové Zámky in southwest of Slovakia. We have mapped the water reservoir or the water bottom with the mapping system of GNSS and sonar, which resulted in the digital elevation model represented as a digital raster digital elevation model. We also have available data in the form of Watershed DEM, which is available from the LiDAR survey that was performed in Slovakia since 2017, which allows us to get the data with a 1 meter pixel, which will help us to decide or assess the surface runoff from this watershed, leading the water to the water reservoir. The principle of current water amount calculation is the usage of water reservoir of DEM of water reservoir bottom, and the assessment of the current water level elevation, which can lead us or which will provide us with the information of the current water depth map which allow us to calculate the current water storage. The current water level elevation is stored or is measured with our prototype. It is Arduino-based system, which is consisting of ultrasonic sensor, which is connected to the Arduino main board. In this case, it's Arduino Mega, and also with the GPRS module, which is dealing with the communication with the database. The data is sent via GPRS connection, which is quite easily to perform and maintain in most parts of Slovak region. In the future, there can be also used the NB-IoT network, LoRa network, or in the case of larger water reservoirs, which are actually currently connected to internet, it can be Ethernet port, Wi-Fi, and so on. As you can see, it is really just a prototype. We have tested it only in laboratory conditions, and for our next task, we are just simulating its data changes, which we will also see. For the assessment or the processing, we have created a simple server-side backend, which is dealing with the PostGIS database, which stores the current data such as elevation models and also current data from the sensors of the water level and also the sensors of the soil moisture. I will talk. Those calculations are performed with the use of Python scripting and PostGIS scripting, which are then feeding the data or the current results to the GeoServer, which is then which will provide the information in services such as WMS and WMS, and those would be fetched by front-end Angular developed web page, which is currently under construction. So we will see only our beginnings of our journey to obtain the result. This work was firstly prepared or maintained or created as a diploma thesis of one of my students, which was dealing with the water reservoir different than we are using currently. In the future, we are also discussing or presuming that we will probably develop maybe a mobile app that will allow the user to have those data available also on the mobile phone, not just with the common web page. If we are talking about the recharge and the amount of water that will flow to the water reservoir, we will deal with the hydrological modeling based on the data from the soil moisture sensors, from the weather forecast, from the soil land use, and so on. Those data are some of those data are currently for the use for free, such as a digital elevation model, as I mentioned, land cover from the Corin, and so on. Open weather map that is providing us currently the information of the weather forecast, and so on. This is how we plan to operate it, and I would like to show you some of our progress. Again, I have to say we are only in the beginning. We are dealing with it only as mostly as a GIS personnel with almost none experience in sensing or sensors. So what we have done, or what we have done till now. Current data we are using, as I said, is the watershed of this water reservoir, and also the water reservoir bottom map that is represented as a raster. Our system on the software, on the server side, is currently processing and feeding us the data as a WMS, which allow us to see how it's advancing or changing the how it is changing in accordance to the simulated data from the water level sensor. If you see, this is water reservoir bottom, and this is how it looks like if the water depth is calculated based on the water level sensor. That means we know exact amount or depth of the water. We know exact depth and water reservoir elevation of the water depth, and we also know the water surface of the given feature, which probably some malfunction, which allows us to obtain the data. I'm sorry, because I'm looking on the live data. Oh, okay. You're right. Not so sure what is happening, but we should be able to see what is current water level, what is current water storage and water surface of the water reservoir in we are dealing with in Mania. Then we are planning to assess it also in accordance to the data from the soil sensors and with the calculation in accordance to the weather forecast. This is what we have, and I have prepared only very few photos of our journey, how to deal with the sensors, because I'm not quite sure if the attendants of this workshop are skilled in sensoring, or the attendants are beginners, as to be honest are we. So our journey started with a very simple task or a very simple project where we were creating a small workshop for the Arduino and Raspberry utilization in GIS and sensoring. That workshop was done, and the users were quite keen on it, because we were dealing with just with very simple tasks, just blinking the LED, working with servos, and calculation of input or utilization of input output from the various sensors, such as photoresistors and so on. I would like to encourage anyone who is interested in this type of work, because as I said, I had no previous experience with all those sensory, but the current situation allows us to obtain the very basic, very cheap sensors for Arduino, for Raspberry, we are dealing or we are talking about tens of euros for the beginning, which are great opportunity to get hand on some real life situation simulations and sensoring, even if those results are not so precise, not so accurate, and so on. But to get the hand on it directly allow us to gain some knowledge, gain some, how to say, experience, and to get better information what the sensoring is dealing with in general. We were also dealing with a small installation of the soil moisture sensors, but it was a bit complicated due to usage of batteries. We were dealing with the capacity sensoring in the field, not in the field, but in the so-called lab conditions in the controlled environment, where we placed a series of sensors. And we, as you can see, it is really prototype. And we were dealing with the sensoring, not with the connection to the internet, but with the storage to the SD card that was later downloaded and analyzed for the further usage. Again, we are only on the beginning. We are learning a lot of new stuff. We have also some results, and I hope this project will lead us somewhere else, and we will be probably able to produce some really interesting results, which can be used in the future for the potential clients, which could be the providers of the information of the water resources, such as Slovak Water Management Institute, or maybe some custom farmers who are dealing with the irrigation system. This is all from my side. I hope, even if it was only really for a beginning, something. So that's all from me, and I would open the discussion if you have any questions for me.
Okay, thank you, Michal and Jakub, for your vivid presentations. So as Jakub said, now it's time for questions. So do not hesitate. You may now unmute yourself and speak, or you can, of course, put the question into the chat as well. Okay, we have one question in chat. If the application FIE20 is already in use somewhere, so it's a question to Michal.
Okay, thank you for your question. At this moment, we have one demo farm involved in the project, FIE20, and we are trying to spread at this moment. So we have another farm in Latvia, and 3 farms in Czech Republic, mainly in, let's say, demo or initial usage. And I would like to mention that this application is really focused on, let's say, small or medium farmers. And with this idea of this application, we were, let's say, in competition for WC's prizes last year. And this application was selected as one of these champions projects. So 100 from 1,020 proposals. So we can say that this idea is really visible for other farmers as well. So at this moment we have 5 farms involved, and mainly in, let's say, starting phase or in testing this phase. Okay, thank you.
Thank you. Any more questions from our audience? Thank you. Okay, if not, so I would like to thank you again to our presenters, Michal and Jakub, for their contributions. Also, many thanks to our team in Plan for All for their support and help in organizing this webinar. And also thank you all behind your monitors, our audience. It is always our pleasure to see that the webinars are seen by so many people. So I would like to ask everyone to register one more. If you have not done it, we will send the recording from the webinar to your email address, and it will also be available on our YouTube channel and everywhere where you can find our Agrihub notes, Agrihub Inspire Hackathon notes. I'm sorry. And any other questions? No, thank you for joining us. Okay, that's the last thing in chat. So I would like to invite you to another webinar, which will be organized this Friday on May 6th at 10 a.m. And this webinar will be dedicated to open land use. So you are all welcome to join us. Okay, thank you and see you soon.
Thank you. Goodbye.
Thank you. Bye-bye.
Thank you. Bye.
Thank you. Bye-bye.